Okay, extension 7.9, factoring polynomials completely. To factor a polynomial with 4 terms, we're going to group the terms into pairs. We're going to factor the GCF, greatest common factor, out of each pair of terms. Look for a common binomial factor. This process is called factoring by grouping. So let's look at this example here. We have 4 terms. Okay, this kind of looks like a little bit of what we had left in our, when we had a greater than 1, right, in our trinomials, and we broke up that middle term. So it's a little bit like that. Of course, you can see now we have a few more exponents to deal with sometimes, but still the same concept. So sometimes you'll be rearranging the terms to get things in common. Looks like we're pretty good right here because the first 2 terms have an x squared in common that we can factor out, and that leaves behind x plus 3. And if we factor out a 2 in the second 2 terms, we get x plus 3. So the common binomial term is going to be x plus 3. So that's one factor. What is left? X squared plus 2. That is your other factor. And then because we're factoring completely, we're going to then look to see, can this be factored even more? And it cannot, so we know that we're done. So let's do several examples of that, and then we'll kind of do a summary of all the different methods of factoring, and then we'll be done with this chapter. And here we go. So let's give it a try. Here, we kind of look and see, yep, we have some common terms. B minus 4, there's nothing in common, but the way this looks like it's going to add up, if I factor out a b squared here, I'm left with b minus 4, and that's what I have here. So remember, it's like I factored out a positive 1 to leave my b minus 4 term. So our 2 binomials, b minus 4, again, the order of the binomials should not matter. Now, at this step, we want to look to see, does this satisfy any of those patterns? And it doesn't. This is non-factorable. We cannot factor this anymore. Moving on to number 2. We have some A's, we have some B's. That should work. So it's just like doing this. We're going to factor out the A. We're left with C plus D. We'll factor out a B, C plus D. So our 2 binomial factors, C plus D and A plus B. Hopefully that was pretty straightforward from what you remember that we've been working on so far. All right. In this one, we want to look around and see if we need to rearrange any of the terms, and it looks like we might need to, because the only thing they have in common here is an S, and it looks like we're going to need to move things around. So I am going to propose that we move these 2 around. So if we rewrite this, 8s cubed minus the 64s squared plus s minus 8. Then we're working with this side. We can factor out an 8s squared. All right, so 8 divided by 8 is 1. 3 minus 2 is 1, so we're left with an s. 64 divided by 8 is 8, so minus 8. And then the s squared cancels out here. So we want to factor out a positive 1 because we want s minus 8 as our other binomial. So s minus 8 and 8s squared plus 1. So that would be our 2 binomials factored completely. Again, we check this, are there any perfect squares? But this plus sign means this is not a pattern that we're used to seeing. This is not a difference of 2 squares because of the plus sign. All right, so why don't you go ahead and work out number 6. And just real quick, so you can check your work in your book, you should have gotten 6a plus 1 and 2a squared minus 5. Nothing else is factorable. So double check that that's what you got. Doesn't matter the order that you have the binomials in, as long as what's inside the parentheses is the same. All right, so now to be considered factored completely. We've seen this pattern right here. This is a difference of 2 squares, meaning that this is a perfect square and this is actually a perfect square. So we could factor it pretty quickly into this. Sometimes we get this as an answer when we're factoring and we think we're done, but we're not. So if it says factor completely, you have to look to see if there's anything else. This polynomial, right, is not a special pattern. There's nothing else that we could break this up into, so it's not factorable. So this is actually factored, and we just saw two examples that kind of did that. It had the x squared plus a number that wasn't a perfect square. All right. So when we want to factor it completely, it's when it's written in a product of unfactorable polynomials with integer coefficients. So making sure that nothing is factorable. So here's your kind of concept summary for factoring completely. First, look to factor out any greatest common factors. And this is also where I would look for any leading coefficients that are negative and factor out a -1. So try to do that first. Factor out a -1 and any other common factors. Then looking for any patterns, right? So we see this, that this is a perfect square and this is a perfect square. So we could go straight to this factored form. If that's not the case, then you're looking for factors of 4 that will sum to a +4. Here, um, if there's no perfect squares, then you can do your AC or rainbow method, looking for factors of -6 that would sum to -5, and splitting this up into groups, and then do it by grouping. And then we just kind of looked at, if we have 4 terms, we could go straight to the factor by grouping step that we practiced when we were learning how to do it that way. So let's give some of these a try. So here, you want to factor out a 3x first, then you're going to factor this. And actually, there are no factors of -6 that will sum to a 2. So there are going to be times when you will have in final factored form, right here, this answer. All we could do was factor out the binomial. So make sure that you play around, maybe even list all the factors and try them all out before you just give up. All right. So don't look at this as, oh, it's factored completely, I'm done. All right. Try everything first. Here, when you factor out the 7x squared, you're left with a difference of 2 squares. So then you can do the x plus 2x minus 2. And now we have everything factored completely. All right, just a few more things to kind of keep in mind. So it looks like I can factor out a 4 for sure. Oh, 4c. I can factor out a 4c. So then I'm left with c squared and then minus 1. All right, so I could think that I'm done, but look at this, perfect square, perfect square. This is a difference of 2 squares pattern. So 4c, and then I have c plus 1, c minus 1. Again, the order in which I write these isn't as important, okay? So why don't you try number 10, pause the video, try number 10. When you're done, looks like you have 25 x squared, and then you had a difference of 2 squares, so 2x plus 1, 2x minus 1. I'm just giving you the answer so that you can double check your notes and know that you got it right while you're waiting to get it graded. All right, so number 11. Number 11. Is there anything that we can factor out? No, we can't factor out a 2. So the AC method, where we take this and connect them and say, okay, I'm going to find factors of -4 that will sum to 3. And the factors of, so 4 and 1 probably, right? 1 times 4, and their difference is 3. Since this is negative and this is positive, then this is going to be negative, right? Because 4 minus 1. So then I rewrite my original. Remember to always keep this original c. So 2a squared, and then I have plus 4a minus 2. And now I can do my factor by grouping, and I can factor out a 2a over here. So I'm left with a plus 2, and now I have a negative a minus 2. So if I factor out a -1, I can get my a plus 2. So a lot of it is just kind of playing around. Negatives and the signs of the numbers are really important. Hopefully you're figuring that out. If you can't get these two to be the same, then there might be a mistake somewhere. So when I write my answer, I will say, and again, the order does not matter, 2a minus 1. This is not any kind of special pattern. This is not a difference of 2 squares. Everything is factorable or factored. So I have my final solution. Okay, let's give a few more a try here. All right. So in this one, I want to look to see if I can, if I need to rearrange anything here, I can factor out the s squared. All right, I think I'm ready to go. So if I factor out an s squared here, I will be left with 3s plus, oh, sorry. See, I changed the variable. I don't know why. 3s plus 2 over here. And then here, it looks like they both have a common factor of 7. Since I want this in between to be positive, I'm going to make it a -7. And then that divided by that is 3s. And then 14 divided by -7 is plus 2. So I have my common binomial factor. So I can write 3s plus 2. Any common factors? Nope. S squared minus 7. Is this a difference of 2 squares? Nope. So we know that we've factored it completely. Okay. Again, kind of looking at all the terms. Any common things that I need to factor out? Negatives, common factors, GCF? Nope. Doesn't even look like I need to rearrange the terms. So I can factor out a t cubed on the left. So then this would leave me with 2t plus 1 over here. Over here, we can factor out a -5, and then that would leave us with 2t, positive 2t, and a plus 1 here. So my factors are going to be the common one, 2t plus 1, and what I pulled out, t cubed minus 5. Okay, and then finally, we are going to be putting it all together. Basically, we're going to be solving an equation by factoring completely. So we've seen this before. We know that we need to make it equal to 0 in order to solve for x. So you'll start by subtracting 10 from both sides. Then you'll look for anything you can pull out or factor out, which they pulled out on, 2x. Then look to see if this is factorable. It is. You get x plus 5, x minus 1. So now we have 2x equal to 0, x plus 5 equal to 0, or x minus 1 equal to 0. So there's 3 solutions, 0, -5, and 1. So let's give some of these a try. All right, so this one's already equal to 0. So I'm going to first look for any common factors. So pull out a 3, and I'm left with x squared minus 7x plus 10. Okay, that's equal to 0. So I want to look for factors of 10 that will sum to a negative 7 and 2 times 5. So if that's positive and that's negative, they would both have to be negative. So I'll have 3, and I'll have x minus 2, x minus 5, all equal to 0. Now, this outside number that I pulled out, the GCF, does not have a variable. So really what we're doing is we're dividing both sides by 3, and that clears this. Oops, it should have just been that. So what we have is x minus 2 times x minus 5, and when we divide this, we get 0. So that just clears it out. If it had a variable, we would have to say that that x from that variable could be equal to 0 as well. Okay, so we add 2 to both sides here, we would get x is equal to 2 or x is equal to 5. All right, number 18, go ahead and factor completely and work that out. And then it looks like for here, y would be equal to 3 or y is equal to -2, just so you can check your work and make sure you did it correctly. Finally, this one, I don't have to put any more shape, but I can factor out a c squared, and then I have c squared minus 81 is equal to 0. And this is the difference of 2 squares. So I have c squared times c plus 9 and c minus 9 is equal to 0. So either c squared is equal to 0 or c plus 9 equals 0 or c minus 9 equals 0, in which case I have c is equal to 0, c is equal to -9, or C is equal to 9. So one of these three possibilities. All right, and that concludes chapter 7.